this video, we're talking about how to add polynomials together. And before we go ahead and look at the examples, I want to talk about what it means to say something is a polynomial. Well, remember that poly means many and nomial means number. So polynomial, we're talking about many numbers. And essentially what that means is that we have multiple terms here, right? We have one term 3x to the fifth, another term 6x to the fourth, another term negative 7x cubed. So we have multiple terms, and these terms can include variables like x's here, exponents like the 5, 4, and 3, and these coefficient terms here, 3, 6, and negative 7, and they can also include these constant terms here like negative fifth. So these are polynomial terms here, and we've got two examples. What we want to do is add these polynomials together. The problem we've been given has sort of divided this into two polynomials for us. The first one is this 3x to the fifth plus 6x to the fourth all the way here to negative 5. The second one is inside these parentheses here, x to the fifth all the way to 3x squared. So we have essentially two polynomials. We want to add them together, but what we're looking for is like terms. Within the parentheses, we don't have like terms in this first polynomial because x to the fifth, x to the fourth, x to the third, and the constant term negative 5, none of those can be added together. Same thing here in our second polynomial, we have different terms. But we do have like terms across our polynomials. For example, here we have 3x to the fifth in the first polynomial, and we have 1x to the fifth in our second polynomial. So we want to be able to add those together. But before we can do that, we need to remove our parentheses. And the way that we do that is remember that we have this implied 1 out in front of our parentheses here. We're saying 1 times 3x to the fifth plus 1 times 6x to the fourth. We can use the distributive property and distribute that 1 across each of these terms. So we remove the parentheses by just saying 3x to the fifth plus 1 times 6x to the fourth is 6x to the fourth. 1 times negative 7x cubed is negative 7x cubed, and negative 5 here. So we've removed the parentheses. Same thing here, we have an implied 1, so we'll distribute this positive 1 and just say plus x to the fifth minus x to the fourth plus 3x squared. Now that everything's outside of the parentheses, we can go ahead and add like terms together. So we have 3x to the fifth plus 1x to the fifth is going to give us 4x to the fifth, and we can go ahead and cancel these terms. Remember that when we're doing this addition, we want to make sure we list our terms in descending degree. So we started with x to the fifth, then we want to move on to x to the fourth, x to the third, any x squared terms, x to the first power, and then our constants. So we started with x to the fifth, now we're looking for x to the fourth. We have 6x to the fourth minus 1x to the fourth is just going to give us a positive 5x to the fourth, and those two are done. And then we have an x cubed term here, negative 7 of them, so negative 7x cubed. Then any x squared terms here, we have plus 3x squared, and that one's done. And all we're left with then is the negative 5. Now, if we take a look at our second example, we want to do the same thing. We've been given two polynomials. Each of them are enclosed in their parentheses. We want to get them outside of the parentheses. Here in front of our first polynomial, we have an implied positive 1 there. So we want to distribute that across each of the terms inside the parentheses, and we get 2x squared plus x to the fourth minus 6x plus 2. Now here's where we have to be careful. Not only do we have the implied 1 out in front of our parentheses, but we have this negative sign here. So essentially we have a negative 1 that needs to be distributed across each of the terms inside our parentheses. So we multiply 10x to the fourth by negative 1, and we get negative 10x to the fourth. We multiply negative 1 by positive 2x cubed, and we get negative 2x cubed. We multiply negative 1 by negative 6x squared. Because we have the two negative signs, they cancel, and we end up with a positive sign, so plus 6x squared. And then the negative 1 times the negative 3, our negatives cancel, and we get a positive 3. With everything outside of our parentheses, we can go ahead and start adding like terms. It doesn't matter which step you do this at. You could do it at the very end of the problem if you wanted to. But remember, like in the first example, we want to make sure that we're ordering our terms in descending degree. So we want to start with the highest degree term first. That's not the first term, that's a 2x squared term. We have x to the fourth terms in here. So we want to go ahead and start with those. We have an x to the fourth here, and we have a negative 10x to the fourth here. So a positive 1x to the fourth minus 10x to the fourth is going to give us negative 9x to the fourth. That takes care of these two. I like to cross mine out as I go so that I remember that I've done these and I make sure I get all my terms. So now we started with negative 9x to the fourth. We're looking for any x cubed terms. So we have a negative 2x cubed here, so a minus 2x to the third. there. Now we're looking for any x squared terms. We have a positive 2x squared and a positive 6x squared. Adding those together gives us a positive 8x squared. And then we have a negative 6x, that's x to the first power. And then a positive 2 plus 3 is going to be plus 5.